Okay, our final type of learning is called learning by observation, or observational learning. The big hallmark of this type of learning is that we rely on what's called modeling for determining what behaviors we should be doing in a given situation. Modeling is what we call imitating the behavior of another. We look at someone else and decide how to behave based on the outcomes that they're experiencing or the status that they're enjoying or whatever. Okay, so here we have an example of two monkeys. It kind of looks like it could be the same one reflected, but it's not. We've got two different monkeys there. The monkey on the right, do I have a picture of what's on the screen for them? Yeah, okay. So the monkey on the right, that's monkey B, he is seeing the motorcycle in the upper left corner, the toucan in the bottom left corner, the statue in the, sort of towards the right upper corner, and then the painting in the right column towards the bottom. Okay, that's his orientation of the objects. So now in the picture that you're looking at with the two monkeys in it, the one on the right, let's say he is touching the picture of the motorcycle, and he receives a food pellet for correctly pushing the button, touching the screen where the motorcycle is. The monkey on the left, as you can see, is watching what the monkey on the right is doing. And here's where it gets interesting and really evidence that he's learning by observation. The monkey on the left sees that the monkey on the right has touched the motorcycle, and that got him a reinforcement. So the monkey on the left is going to find his motorcycle, which is not in the same position as it is for the monkey on the right. So it's not that he's just pushing the same spot on the screen. He literally sees that the monkey on the right pushed the motorcycle. So the monkey on the left finds the motorcycle, pushes the motorcycle, and he also gets a food reward. The monkey on the left does not need to be directly reinforced to figure out what the correct behavior is in this situation. He sees that the other guy got reinforced. He wants that same reinforcement. He does the same behavior. He imitates the behavior of another. So monkeys do it, humans do it, dogs do it. Why do we do it? Well, about 15 years ago, researchers discovered that in our brains we have these neurons that are labeled mirror neurons. They've been called a lot of different names. Some people call them the monkey see, monkey do neurons, but that's a little cumbersome. Mirror neurons are specialized neurons that become active when you are observing somebody else's behavior and putting yourself in their place. On the left, we have a person who's actually experiencing pain, and this is what's called a functional MRI. We talked about this earlier in Chapter 2. And so the computer has colorized those parts of the brain that were most active during the experience of pain. And you can see towards the top of the brain there's a lot of, the parietal lobe, the sensation area that's activated because they're in pain and they're feeling something. And then you see over on the left temporal lobe a lot of activity. The yellow and the white is really highly active areas. So here we are on the left temporal lobe with a lot of activity going on. The person on the right is not experiencing pain. They're watching someone else experience pain. And so you'll notice nothing up in the sensation area is lit up in the brain of the person who's experiencing empathy for the person who's in pain. Instead, you see certain little areas there in the left temporal lobe that have lit up, that are active during the observer's experience of empathy for the person who's experiencing pain. That region of the brain activating like that is evidence of these mirror neurons. When I see somebody else experiencing something, it's as if I'm experiencing it myself. Not a full experience, because you'll notice there's only just localized areas of the brain that are activated, but it's as if I'm experiencing part of it myself. And so when I see my fellow monkey get a reward for pushing the motorcycle picture, my little brain sees that and says, oh, it's as if I pushed it myself and I got to reward myself. I'm going to do it too. And so thanks to those mirror neurons, we will imitate behaviors that we've seen other people engage in, or we will avoid behaviors that we've seen other people engage in that resulted in punishment. So observational learning is in a large part fueled by the action of these mirror neurons. Okay, now observational learning begins when we are really young. I tried to find a human picture of this, but I couldn't find one, so I found this really awesome monkey picture. So what we find is the human on the left is sticking out his tongue, and you see that baby rhesus monkey is maybe 2 days old max, based on his little physical development. So he's a very young little rhesus monkey. The human on the left sticks out his tongue and the rhesus monkey is staring at it. In the next panel, you see the little tiny rhesus monkey tongue sticking out as he imitates the behavior of the human. You could do this with a newborn human and it works the same. They've got to be acutely awake, paying attention to you, but if you stick out your tongue, they'll stick out their tongue. It's a precursor to the more elaborate kinds of observational learning that we'll expect to occur as the baby grows. Here's a toddler. He's watching a guy on TV who has some objects in his hands that match the same objects that the toddler has in his hands. And what you see in these kinds of studies is that the toddler will look to the adult for how to play with the toy or how to interact with the object, and then they will model the exact same behaviors. This is good. This is a good strategy for teaching the next generation what to do and how to do it, right? It's a really effective technique. One of the downsides that we've learned about the baby or the toddler or the young child's propensity for looking to adults for how to interact with objects in the world is that if the adult uses an object that has lots of different uses, let's say a ball, and shows the toddler how to use the ball, it actually will reduce the amount of creativity that that toddler shows while playing with the ball, compared to toddlers who are just left alone with a ball and they come up with whatever else they might want to do with it. Models sometimes will narrow our creativity and reduce our the number of responses that we might produce, because we think, okay, well, this is what you're supposed to do with it, rather than exploring all the possible uses for it. So observational learning certainly allows for transmission from one generation to the next of skills and knowledge and social mores and norms and stuff like that, but it also can be a little bit self-limiting because now we're only going to do what we've seen other people do. The main researcher who is most famous for learning by observation would be Albert Bandura. Bandura is really famous for what we call the Bobo doll study. Here are a series of snapshots from one of the variations of the Bobo doll study. The Bobo doll is that inflatable doll that has a clown painted on it, and then at the bottom there's a pocket filled with sand, so that when you punch Bobo, he automatically pops back up. It is a reasonably popular toy in the 1960s, and really there's nothing else to do with Bobo except for punch him and kick him. I mean, that's sort of what you do with Bobo. But in the Bandura study, what he did was he got adult models. This woman was one of the adult models. The other one was a man. And some of the little kids watched the film strip that contained the woman, and some of the little kids watched the film strip that contained the man, just to sort of balance the sex variable of the model. Bandura got the adults to do some behaviors with the Bobo doll that were not normal things that kids usually came up with on their own when confronted with a Bobo doll. So you'll notice the lady, even though she's wearing a pencil skirt and pointy-toed high heels, she's straddling the Bobo doll and punching him in the face in the left-hand frame. In the middle, she's throwing him, and on the right-hand frame, she's hitting him with a toy hammer. So these are things that when Bandura was setting up the experiment, he had kids play with the Bobo doll, and he did not see a single child emanate any of these behaviors naturally. So he's like, okay, we'll have the adult model these odd behaviors that are not typical, and then we will have children watch the film strip of the adults interacting with Bobo, and then we'll give them free play with Bobo. And so see a little boy here, and then we have a little girl here, and what you see is them modeling exactly the behaviors that they saw the adult doing. And it turned out it didn't matter whether it was a male, it didn't matter whether it was a female model, it didn't matter whether the child was male or the child was female. Seeing the adult engage with Bobo in these ways led the children to engage with Bobo in these ways. Now, these findings led Bandura to assert that watching examples of aggression on TV will lead children to model those aggressive acts. And this has been the source of a huge debate in psychology ever since the 1960s, when Bandura first did the Bobo study and first asserted that watching people on TV behave violently will make children behave violently. The thing about the Bobo study that makes it a little bit self-limiting as far as being able to extend it to you watching violence on TV and then behaving aggressively is that everybody who interacts with a Bobo doll behaves aggressively towards the Bobo because there's really nothing else to do. So every child who interacted with the Bobo, whether they saw a model or not, punched Bobo, kicked Bobo. Some of them sat on Bobo, but not in the straddle and punch format. But, I mean, there were a lot of things that the kids did that were aggressive because that's what Bobo demands. There's nothing else to do with it. There's literally nothing else you can do with Bobo. So having an aggressive eliciting doll as your stimulus and then giving the children ideas for how to behave aggressively does not necessarily mean that they would see somebody behaving aggressively on a TV show, like let's say beating someone up on a TV show, beating a human up on TV, that they would necessarily then beat up another human in real life. It's sort of different. Bobo begs to be punched. Your sibling does not necessarily beg to be punched. So it's not exactly the same thing, and so a lot of people have really argued about, you know, the extent to which Bandura sort of just generalized to all aggressive behaviors. In response, Bandura did a flip of the study where he actually had adults who behaved in a pro-social way towards Bobo. They would hug him, they would pat him on the head, things that people don't normally do with Bobo because, like I said, you punch and kick Bobo. There's no, you know, hugging Bobo. So the models hugged Bobo, the models kissed Bobo. And what you found is that the children who saw those models still punched Bobo and still kicked Bobo, but then they would give him a hug afterwards, or they'd give him a kiss on the cheek afterwards. So yeah, they come up with strategies for how to engage with the doll, but it did not override their tendency, their natural tendency to punch the doll, because that's kind of what the doll asks for. I mean, that's what he was made for. There's nothing else to do with the doll. Okay, so that concludes the different kinds of learning. Our next chapter is going to talk about memory, which is sort of a more cognitive type of learning. So we'll come back and talk about memory in our next chapter.